Energia de Fusão, uma nova era de investimento e inovação.
A new phase in the quest for fusion energy is underway, driven by surging investment, bold timelines from government leaders, and ambitious projects stepping into the commercial arena. The promise of clean, almost limitless power from the stars is no longer just scientific aspiration, it's becoming a roadmap for the future. U.S. Energy Secretary Chris Wright has set out an assertive schedule. He told the BBC that advances in artificial intelligence, together with private sector innovation and work at national laboratories, are expected to bring breakthrough developments in fusion within the next 5 years. He further projected that fusion technology could begin delivering power to electricity grids globally in 8 to 15 years. These statements mark some of the most concrete timelines yet from a senior government official. They reflect both the urgency and optimism surrounding the field. Venture capital, strategic investors, and clean tech backers are increasing their exposure to fusion energy in a big way. Commonwealth Fusion Systems raised about $863 million in its latest funding round, bringing its total capital raise to nearly $3 billion since it spun out from MIT in 2018. The CEO of CFS, Bob Mumgard, has emphasized that this funding supports key milestones, including completing the Spark demonstration machine and developing their ARC power plant in Virginia. According to data from the Fusion Industry Association, over 30 fusion companies are aiming for pilot power plants to be operational by the early 2030s. In the past year alone, private investment in fusion has surged by $2.6 billion, a 178% increase from the previous year. These numbers reveal growing confidence among investors that fusion energy is transitioning from the laboratory to a near-commercial reality. The reasons for investor confidence are tangible. In 2022, researchers at Lawrence Livermore National Laboratory achieved a landmark moment, producing more energy from a fusion reaction than was required to initiate it in a controlled lab setting. This kind of net gain has become a foundational proof point. Advances in superconducting magnets over recent years have improved confinement of plasma at extremely high temperatures, one of fusion's toughest engineering challenges. Dozens of projects are underway to develop improved lasers, more resilient materials, and new reactor designs. Some projects are already reaching for the grid. Helion Energy, backed partially by figures in the tech world, hopes to deliver electricity within 3 years to Microsoft under a power purchase agreement. Commonwealth Fusion Systems has secured a future power purchase deal with Google for 200 megawatts of electricity from its future plant. The Spark pilot project is expected to demonstrate net positive energy and serve as a stepping stone to larger commercial plants. These agreements show how fusion companies are trying to pre-position themselves with customers ahead of wide deployment. Even as optimism rises, experts warn that significant hurdles still stand in the way. Scaling lab successes into reactors that reliably produce more energy than they consume is not yet achieved. Materials capable of withstanding the extreme neutron flux, heat loads, and long operational lifetimes are still under development. Fuel supply, especially of hydrogen isotopes like tritium, presents logistical and scientific difficulties. Regulatory frameworks, safety standards, cost control, and grid integration are still evolving. Some analysts caution that if breakthroughs do not occur on the expected schedule, investor patience could strain and public expectations might suffer. The fusion energy landscape is deeply international in scope. Investments are flowing not only in the United States, but also in Europe, Japan, the UK, China, and other hubs of science and industry. Reports suggest that fusion power, if deployed at scale, could surpass coal in global power generation by mid-century under certain cost and emissions constraints. Governments are announcing large funding packages. For example, the U.S. Department of Energy has allocated $134 million to advance fusion, supporting both research to commercialization pathways and technical work on key components like magnets and lasers. The period ahead will be a clear test of whether fusion is transitioning from possibility to practicality. Demonstration plants like Spark and others will need to deliver consistent performance. Early commercial deals will test not just technical viability, but also economic viability. Governments must continue to address regulatory, materials, and supply chain challenges to avoid bottlenecks. Investor confidence will depend on measured progress, not just promises. This is a pivotal moment. Scientific proof points have been crossed. Funding and commitment are mounting, yet the journey from the laboratory to reliable, affordable clean power still has steep terrain ahead. The coming years will determine whether fusion fulfills its promise or remains a tantalizing horizon.